All right, I'd like to start this video with a derivation of the quadratic formula, just in case you wanted to know where the quadratic formula came from. It actually comes from our equation in standard form, 0 equals ax squared plus bx plus c, where we start with this and we solve for x. So what we're going to do is start with that equation, and we're going to use the technique of completing the square to isolate x in this equation. But since we have all of these variables, they're just going to stay as variables as we solve for x. So first thing I want to do is get rid of my a term. So in order to do that, I'm going to have to divide everything by a. It's exactly what you would do if you're solving an equation with completing the square if you had actual numbers, but we just have these coefficients. So I get x squared plus b over a x plus c over a. All right, so now I'm going to complete the square, but with just the variables. This is doable. So when I do that, I create this structure here. I keep my last term, which in this case is c over a. And for this value here, it's always 1/2 of this value here. And to get half of a fraction, I can just multiply the bottom by 2. So that makes it b over 2a. And then I've got to subtract away this value squared. That's going to be b squared over 4a squared. So 2a squared becomes 4a squared. I can show that scratch work real quick. B over 2a squared equals b squared over 2a squared, which is where this came from. This was the extra. That's what we've been calling it when we've been completing the square. All right, so this is going pretty well. Next thing I'm going to want to do is combine these two terms at the end here. Sort of just a way of simplifying it. To do that, I need to multiply this one here. Let me show it actually up here. I got to get a common denominator, so I'm going to multiply it by 4a over 4a. That's going to give us 0 equals x plus b over 2a squared plus 4ac over 4a squared minus b squared over 4a squared. All right. Next step, let's combine those. I get 0 equals x plus b over 2a squared plus, I'm going to rewrite this in the way that it actually looks in the quadratic formula. It's negative b squared plus 4ac. And it's all over 4a squared here. All right, I need to subtract this big fraction from both sides. So I'm going to subtract it from here, I'm going to subtract it from here. I'm going to essentially move it over here and make it negative. So after I do that step, now I've got negative b squared plus 4ac all over 4a squared equals this binomial squared here. Next up, I'm going to take a square root of both sides. That's going to cancel this here. And I'm going to be left with, so now square roots are always positive and negative. So plus or minus, let's let me distribute this negative here. That's going to make that a positive and that a negative. So plus or minus the square root, and this is one big square root, of b squared minus 4ac all over 4a squared equals x plus b over 2a. All right, this is looking very similar to the quadratic formula. In this step here, I'm going to go ahead and subtract b over 2a from both sides. So now my equation looks like negative b over 2a plus or minus, and I'm going to distribute that square root to the top and the bottom of that fraction. So I get the square root b squared minus 4ac all over the square root 4a 4a squared equals x. Now right here, the square root of 4a squared is equal to the same thing as the square root of 4 times the square root of a squared, which is the same thing as 2 times a. So that is the same thing as 2 times a. So these now have matching denominators. So we're just going to combine them into one fraction. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and that exactly matches what we've seen so far for the quadratic formula. But now there is where it came from. We start from very humble origins, just 0 equals ax squared plus bx plus c, and through some algebraic steps, we're able to get to our quadratic formula. And right at the beginning, we used completing the square to get started on this problem. All right, so now let's do some problems from the homework. Let me zoom in on this. I think number 2 is a good one. Number 2, I do not believe is factorable. I do not believe there's any two numbers that multiply to be negative 15 but add to be negative 12. So completing the square is a good option for this one. I'm just gonna, we don't have an a value, so we can go just right into it. N, big parentheses, squared, keep that minus 15. Now I fill in these values with half of the b value, negative 6, and then subtract away that value squared. So it was half of that value, subtract away that value squared, the 15 just kept there, and we always have these parentheses in the squared. All right, so now I've got n minus 6 squared minus 51 equals 0. Keep going, I add 51 to both sides. And the reason this works out so well is now if you look, as soon as I rewrite it, at the left side of this equation, thing is squared. It is n minus 6, that entire quantity squared. So now taking a square root is going to just cancel out that squared. And we're going to be left with n minus 6 equals plus or minus the square root of 51. That can't be simplified. The square root of 51 is irrational. So we'll just leave it like that. Let me add 6 to both sides. And we'll just call this our final answer. N equals 6 plus or minus the square root of 51. Now if you want to get decimal, you can go ahead and plug those into your calculator and you'll get these decimals here. 13.141 and negative 1.141. All right, let's see. Let's do an example of a problem that has an a value. I think, yeah, number 7 is a good one because we end up with some decimals. I'll show you how to deal with those. Let's start by adding 6 to both sides. Now I've got 7x squared plus 14x minus 68 equals 0. I want to get rid of that a value, so I divide everything by 7. And now I get x squared plus 2x minus 68 sevenths equals 0. Let's go ahead and complete the square now. I've got x plus 1, always half of that b value, squared, minus 68 over 7 minus 1 equals 0. Just going to keep going straight down here. I can combine those two constants. I just have to convert that minus 1 into a negative 7 over 7. And now I get a different color, x plus 1 squared minus, let's see, 68, negative 68 minus 7 is going to be a negative 75 over 7 equals 0. Let's add that 75 over 7 to both sides. Now I get x plus 1 squared equals 75 over 7. Take the square root. And just keep going down. We get, no need for parentheses, just x plus 1 equals the square root of 75 over 7. That's a plus or minus the square root of 75 over 7. Keep going down. Subtract 1 from both sides. And I'm going to leave my answer like this. X equals negative 1 plus or minus the square root of 75 over 7. Now convert that to a decimal if you want. This is the unsimplified answer here for that problem. Let's see, looking for another tricky one. 13 looks pretty tricky because we got all these like terms. Let me start by gathering my like terms by subtracting 7n squared from both sides. That gives me an n squared plus 10n plus 75 equals negative 10n. Now I'll add 10n to both sides. Now we would not be able to do completing the square if we didn't have a b value. It just wouldn't really quite work. Also, it wouldn't be the appropriate method because we could just solve by taking square roots. Here we do have a b value, but just wanted to point that out. All right, let's rewrite this using the structure. Keep the 75. Now right here, I write half of that b value, then I subtract away that squared. This is all equal to 0. Let's combine our like terms. N plus 10 squared minus 25 equals 0. We'll add 25 to both sides. N plus 10 squared equals 25. Now that the entire left-hand side is squared, I can take square roots and they'll cancel out. This brings us to, write it over here, n plus 10 equals plus or minus 5. I'll subtract 10 from both sides. I get n equals negative 10 plus or minus 5. Let me split that into the two different cases. You've got n equals negative 10 plus 5 as one case, and you've got n equals negative 10 minus 5 as the other case. Simplify one more step and we get n equals negative 5. and n equals -15. That was for problem 13. Let's see how we did. 13, -5, -15. All right. Solve with the quadratic formula. Let's just do one of these and then call it good. Looking for somewhat unusual one. All these look like they're not too bad. I guess 16, just because we have an a value that isn't 1. When I solve using the quadratic formula, the first thing I do is I write out what each of the values is equal to. A equals 2, B equals 5, C equals -25. Those all come from standard form ax squared plus bx plus c. All right, then I write out my quadratic formula. Negative b plus or minus the square root, b squared minus 4ac, all over 2a. And then I substitute my values in. And when I substitute the values in, I make sure to do it inside a set of parentheses to help avoid making mistakes with positives and negatives. The most common mistake is just a positive-negative number mistake. And now, after setting it up, we just follow order of operations. We follow PEMDAS. We do all of this multiplication before we touch that subtraction. It's another common spot to make a mistake. So here we go. I've got -5 plus or minus the square root of 25 minus, this is actually going to be a negative 200. Double check that. All divided by 4. This leads to -5 plus or minus the square root of 225. All divided by 4, which equals -5 plus or minus 15 divided by 4. And from here, we can split it into the two cases and solve each. You get -5 plus 15 over 4 and -5 minus 15 over 4. This gets you 10 over 4. We'll just leave it like that. And -20 over 4, which will simplify to be -5. All right. So finish up that homework, and I will see you in class.